All right, yesterday we talked about dx cut and dy cut, so your class starter today is just determining which one to use. So you're going to look at these four graphs and determine if it should use a dx cut or a dy cut. Remember, dx cut is written in terms of x. You don't have to set anything up here, but this happens when there's one function that's above the other one the whole time. And a dy cut happens when there's one function that's to the right of the other one the whole time. So take a look at these four graphs and determine what you think it should be, a dx cut or a dy cut. Then you can talk and check with your partners, and we'll go over the answers in about a minute. All right, about 30 seconds. All right, let's take a look at number one. We have this shaded region we're looking at, and it's created by two graphs, the red one here and the blue one. So we have to determine in that little shaded region, is one of these graphs above the other one the whole time, or is one to the right of the other one the whole time? Well, in this case, we have the red one that's above the blue one the whole time. Remember, one way we could determine this is by using vertical lines. If we draw vertical lines through here and it always goes through the one function first and the other one second, then it's going to be a dx cut. So you can see here, it always goes through the red function first on top and then the blue one on the bottom. So we have a dx cut. For number two, we have two graphs here creating our shape, this purple one and this green one. In this case, it's not a dx cut. If you look here and use vertical lines, it doesn't always go through the same graph first and then the same graph second. Here, it's going through the purple graph and then the purple graph, but over here it goes through the purple graph and the green graph, so it's not going through the same thing throughout this whole interval. So it's not going to be a dx cut. In this case, it's going to be a dy cut. And we can check that by doing horizontal lines. Right? Horizontal lines here go through the green graph on the right, purple one on the left. So the green graph is always to the right in that area. So this is a dy cut. Remember, that just means we're using little horizontal rectangles with a thickness of dy to find the area. But we're using the shortcut with integrals instead of the limit of the sum. In number three, this one is going to be a dx cut because the one graph here is always above this one in that little gray region. Right, so that's the top graph. This is the bottom graph. And in number four, this one is going to be a dy cut. This graph right here is always to the right of this one during that gray region.